Hello, everybody. Welcome to our next lecture on electronic markets titled Pricing in Two Side Markets Platform Competition. Yeah. So, the agenda for this talk is going to be again monopoly competitive pricing, which is going to focus on pricing under monopolistic competitions in traditional markets. Then we're going to look at pricing under monopolistic competition in two-side markets, membership fees, based on Armstrong, and then we're going to look at pricing under competition in two-side markets where there's membership fees and transaction fees. So let's start with the model of monopolistic competition. Yes. Um, so again, as before, the model is with heterogeneous consumers. Again, we employ the Hoteling framework. The market region is described by the interval 0, 1, where consumers are distributed according to their shopping costs or their transportation costs. This is basically the preference parameter. And consumers are uniformly distributed over that market region. Total consumer mass is normalized to 1, and the location of consumers X denotes his preference for a platform over the other. Okay, there are two firms that offer goods and are located at the extreme points of the unit interval 1 and 0. Okay, 0 and 1. Okay, consumers receive a base utility of V1 or V2 if they buy a good from firm J, that is 1 or 2. Firms have constant unit costs C1 and C2, okay, and firms charge prices. Every consumer intends to acquire 1 unit of the good, so it is in a sense unit demand, and a consumer located at position X in 0, 1 has to spend a transport cost of tau in order to in the amount of tau into where its location is minus X for buying a good from firm J. Okay, actually from firm K. I think the J is not, it's not J, it is actually K. Okay, the utility of the consumer is then just given as UK, where VK is the utility of consumer from buying from the platform J, no, from platform K with price PK and not PJ, apologies for that, is VK minus PK. That is the utility it gets for consuming the good minus its preference parameter, where tau is the transportation cost and how far away it's from the firm, xk. Okay, xk minus x. And then we can denote an indifferent consumer x tilde on that line who is indifferent between the two platforms, where it would be gotten by setting the utilities of a consumer who's located at the two platforms, and when the consumer is indifferent between the two platforms. Okay, there's basically so suppose there are two, since there are two platforms, it'll be v1 minus p1 minus tilde x tau, and v2 minus p2 and 1 minus x tilde, because the other platform is located at the coordinate 1, right? In case of symmetric utilities, it would just base utilities, it will just look like where v1 is equal to v2 is equal to v. This reduces to the following expression, okay, because v's get cancelled, out. So all consumers with x less than x tilde receive a higher net utility if they buy the product at x1 equal to 0, and for all consumers x greater than x tilde, this indifferent consumer, receive a higher net utility if they buy the product at x2 equal to 1. Okay. So just to give you an illustration, the market shares with heterogeneous consumers, this is what it's called by spatial or horizontal differentiation, is under the assumption of v1 equal to v2 is given as follows, where consumer valuation at 0 is this, and it increases linearly. Okay, So where the the incremental utility compared to the other is given here, where costs if X buys at firm 2 is the green line, and costs if X buys at firm 1 is the yellow line. Okay, so the indifferent consumer is when the two lines meet, right? Because if you see here, it is exactly what you see, right? In the this is the expression that allows us to pinpoint the indifferent consumer, and here this is what it's doing. Okay, so we get the indifferent consumers when the costs at the two platforms are being matched under the assumption that v1 equal to v2 equal to v. Okay, that is, they provide the same utility. Okay, and next, given the demand, the indifferent consumer is located x tilde. The demand for firm 1 who's located at 0 would be d1 and is given by x tilde, which is this expression. Okay, and here we don't have we don't use the assumption of v1 equal to v2, and we allow v1 and v2 to be kind of different. And for d2 it is just 1 minus x tilde, which is again this expression. Okay, just 1 minus the d1. Okay, then the firm's profits are given by p1, which is its margin from selling to consumers, and the demand they get, right? So this is basically the profit as a function of p1 and p2, right, of the prices. Then what we can do is basically take the first order conditions which allow us to get the best response function. What are those? A best response function describes a profit maximizing strategy, pk, of a firm k as a function of its competitor's price, pj. So given the competitor's price, what would be my best response? Like, what is my response that would give me the best profit? Okay, maximizing profit. Okay, so if every firm maximizes its profit given the behavior of the competitor, we can then get the firm 1's first order condition or as given as follows, and for firm 2's first order condition given as follows, which allow us then to get the best responses as a function of the rival strategy. So basically here, when you solve this, the firm 1's first order condition, for P1 we can get P1 as a function of P2, which is its best response given the rival has set P2. Okay. Similarly, employing the same method, we can get P2's best response as a function of P1, which is basically solving the first order condition of firm 2 with respect to P2. Okay, and we can get, now this is basically the first order, the best response of P2 with respect to P1. So normally the Nash equilibrium is just the intersection of the best responses, right? And that is what we are trying to do here. And under symmetric valuation, v1 and v2, and the cost being symmetric as c1 and c2 being c, we can solve and we get that the price of the two platforms is also going to be symmetric and given by tau plus c. How do we get these prices? By solving these two best responses simultaneously. Okay. The transport cost parameter is a proxy for the level of product differentiation. It's basically it can be also seen as the competition intensity in the market, and this decreases with a higher tau. Okay, and the price of two firms increase with higher tau. That is, as the firms are competing less, firms are able to charge a higher price. The limiting case when the transportation cost goes to 0 yields the perfect competition case where we have that the prices are equal to the marginal cost, right? This is, we already know from Bertrand competition. Next, we move on to pricing under monopolistic competition in two-side markets where there are membership fees. Okay, membership fees are very common in compared to two-side markets where elite partner versus Parship are competing, or for instance, newspapers are competing. Okay, so we use the model as described by Park and Van Alstyne, where using the additive recursive model. Okay, so again, we're trying to understand now how membership fees are being set. and now in two-side markets, and we again assume that there are two platforms located at two extreme points of the unit interval, where platform 1 is at coordinate 0 and platform 2 is at coordinate 1. Platforms have cost CC on the consumer side and CS on the supplier side. There is a unit mass of heterogeneous consumers, QC1 plus QC2, where the total set of consumers is equal to 1, and they're distributed on the unit interval. There's a unit mass of heterogeneous suppliers who are also distributed on the unit interval and uniformly. And we assume that consumers and single home and suppliers single home, and each consumer and each supplier visits only one platform. Basically, that's what it means. Okay. So let's try to understand how the two-sided demands are obtained. So basically, we try to obtain the indifferent customers on both the sides, right? Suppliers and consumers face an opportunity cost of visiting a platform that increases linearly in distance at the rates tau c and tau s, which is also the differentiation parameter, Hotelling parameter. And net utility of individual suppliers and individual consumers is given as follows. From joining a platform I is basically UIS is the net utility of suppliers, which is UI of where VS minus PIS is the price being paid for by suppliers on platform I. This is the value being created, and this is the transportation cost. Okay, and again on the consumer side, which is the this is the value being created for consumers minus the price being charged to consumers and the additional value that they get from the presence of suppliers on the platform. Okay, and this is the transport cost. So just to simplify notation, what we do is we call UI tilde as the net utility, okay, which is how much they gain from the kind of the standalone value and the prices, and how much they value consumers. Okay, how much value consumers provide to each supplier, and similarly for consumers, this is the standalone value for consumers and the prices plus the value that they obtain from the presence of suppliers on the platform. Okay, then we can rewrite the indifferent consumer as follows. There's a standard Hotelling condition as well for consumers and for suppliers. Okay, these are the two indifferent consumers and suppliers. And then platform specific demands for each market is then just for the consumers is just for platform I is half plus UI tilde minus UJ tilde, and for the suppliers is again the standard the indifferent consumer. Note that this is actually the demand for platform 1, and for platform 2 is just 1 minus of this. Okay, so it's coming here, and so using the idea that it's a Hotelling setup, and then the demand for platform 2 is just 1 minus QI of C, and then similarly for suppliers on platform J is just 1 minus QIS. Okay, and we'll then simplifying a little bit, we then basically get the demand on platform I from consumers is just the following expression. Similarly for demand from sellers on platform I is the following expression. What can we see? For given membership fees PIC and PJC, an additional supplier attracts ESC by tau C additional consumers. So if you see on the consumers, an additional additional consumers, right? So what do you see? An additional supplier attracts ESC by tau, right? Additional supplier consumers, and similarly one additional consumer attracts ECS by tau s additional suppliers. This can also be then seen here. Okay, then solving for QIC and QS simultaneously yields the price dependent demands for each market, which is given here. Okay, And this is basically what you do is you solve QIC and QIS simultaneously, and you can get these demands here. Then what is the profit function? The profit function of a platform I is then the demand from consumers and the margin on consumers. Similarly, it is the demand from suppliers and the margin on suppliers. Then the two platforms simultaneously choose membership fees on both sides of the market, where the price being charged to consumers is just obtained from taking the first order conditions, and this is the first order conditions with respect to the price being charged to suppliers. Okay, and these two have to be equal to 0 and then solve simultaneously for all. So there's actually going to be 4 first order conditions that we solve simultaneously, right? And to understand further. Further, imposing symmetry, we know that then, after taking the first order conditions, we can impose symmetry because we know the platforms are ex-ante symmetric. Then the price, the price of the two platforms are going to be the same on the consumer side and on the seller side. And then we just get, the price of platform I as a function of how much it charges to the sellers. And similarly for sellers as a function of how much it charges consumers. And then solving these two simultaneously, we can basically get the equilibrium prices are the price on suppliers, what is the transportation cost, plus the cost of supplying or selling to sellers, minus or suppliers, minus the value that each supplier offers to consumers. Similarly, the price to consumers is going to be the standard transportation cost plus the cost of servicing consumers minus how much each consumer provides, value it provides to suppliers. Okay. Next, comparing this with the optimal price setting in one-side markets in a hoteling setup, we know that the price on the two platforms was just C plus tau. But now, what we notice is that now the price being charged to sellers and consumers has an additional term, right? ECS and ESC. So what we can conclude is that cross-site network externalities influence membership fees not only under a monopoly but also under competition. A firm that internalizes cross-site network externalities sets lower prices, and that's actually the job also of the platform. And further, the side of the market that exerts a stronger indirect network externalities, ECS or ESC, on the other side tends to be subsidized compared to the other side. Okay. Similarly, what we can do is using price elasticity of demand, the equilibrium membership fees can again be interpreted based on a quasi-Lerner index, which is given as below, which we get from the first order conditions. This is basically the elasticity of consumers given a price C and given fixed all the number of suppliers. Okay. And comparing with the optimal pricing of a monopoly platform, in duopoly, the platform puts twice as much emphasis on the cross-site benefits exerted on the other side when it sets a price. Rationale for this is as follows. In the case of platform competition, the loss of a consumer has negative impact on the supplier's valuation of the own platform, but additionally also makes the competing platform more attractive to suppliers because the consumer joins the other platform. So, lesson 1 that we can get from here is that the side of the market that exerts a stronger indirect network effect on the other side tends to be subsidized. Prices are lower on the side that evokes stronger cross-site network effects. In a market in which consumers and suppliers choose one of the two platforms, membership fees react more strongly to network effects than in a market with single platform. The strength of the indirect network effects determines whether more than one platforms can exist in equilibrium. In particular, two platforms cannot be active if indirect network effects are too strong relative to the degree of horizontal differentiation. Next, We try to understand platform pricing under monopolistic competition and when there's multi-homing. So, what is the first we try to understand what are the effects of multi-homing. So, suppose we impose that at most one side can multi-home, and there's no additional gain for consumers if both sides multi-home. Okay, for example, consumers single home, but suppliers can multi-home. Then a supplier lost by one platform is not a supplier gained by the other platform, right? Platforms are more concerned about losing consumers because they single home, right? So platforms compete fiercely for consumers, which tends to low and possibly even negative prices for consumers accessing the platform while charging suppliers for access to consumers. In a market with competing platforms, in which suppliers can access both platforms simultaneously, multi-homing, while suppliers have to bear membership fees and consumers pay lower membership fees. Since consumers are valuable to extract, this is because consumers are valuable to extract profits on the supplier side, platforms tend to compete fiercely for consumers, whereas they milk suppliers. This is basically the lesson for coming from, this is also coming from multi-homing of one of the sides. This is also called something competitive bottleneck in platform terminology. Next, we move on to pricing under competition in two-sided markets where there are membership fees and transaction fees. This is based on a famous paper by Keio and Juya in 2003. For this, we use a multiplicative recursive demand, which is given here. So we're going to use the model matchmaking environment model as in their paper. So agents on one side value the matchmaking services of a platform more when participation on the other side is high, because a large pool is more likely to lead to a successful match. Examples of this are business-to-business electronic marketplaces or ride-sharing platforms or dating platforms. This generates cross-identity network effects, leading to a winner-takes-all situation if intermediaries are homogeneous. So just to provide you some insights on the preliminaries of the game, there's a population of consumers QC which is equal to 1, and with QC1 and QC2 are the consumers going to the two platforms, and a population of suppliers which is also set at mass 1, where QS1 is the number of suppliers on platform 1 and QS2 is the suppliers on platform 2. And there are unique trading partners in the other population who the trading partner can find only by using the matching services of an intermediary. Okay, that is the platform. If two matching partners are registered with the same platform, the probability of finding each other is equal to lambda, which is the probability of a match. If a number QIC, that is the number of consumers on platform I, registers with the platform, then the probability of a supplier to find this match is just equal to lambda into QCI, okay? And platforms compete in prices, okay? So registration or membership fees are denoted by on platform K is denoted by and MKI. Total transaction is denoted by how much the platform I charges to consumers plus how much the platform I charges to suppliers. Okay, gains from trade in case of successful match are normalized to 1 and equally shared between the trading parties. Efficient bargaining process. Per match net gain per trading partner is just 1 minus PI by 2. Okay, this is basically saying that the total value is 1 and this is how much I charge, kind of how much value that you can get, taking into account the price you pay to the platform. And then further assumptions of the game are that the expected utility registering with platform I is for consumers is the total number of sellers on the platform I into the probability of being matched with the seller into the gain from the match, right? There's 1 minus PI minus the fee that is being paid to the fixed fee or the membership fee being paid to platform I by consumers. So also the expected utility for a seller on platform I is again the total number of consumers on platform I multiplied by the probability of success into how much price is being paid by sellers on platform I. Okay, minus the fixed fee that sellers pay to the platform I, or the membership fee. Okay, so then the total profit of the platform is just the quantity or how much, how many sellers or consumers join the platform into the membership fees. So there is also a per consumer membership, kind of cost, plus the price PI being charged for the transaction. Okay, so transactions are totally transactions if there is a match, QCI into QSI, right? Where CC and CS are the costs a platform incurs when providing services to one consumer and one supplier, respectively. Okay, so the timing of the game is as follows. First, platforms simultaneously set their price structure. Then agents choose which platform, if any, to register with. And then agents can register with at most one platform, and utility is 0 if they do not register. Next, we try to first understand something called divide and conquer strategies. An equilibrium game is a pair of price structures, MC1, MS1, and P1, where these are the fixed M's are the membership fees, and P is the price charged to the two sides. It's the sum of the price being charged to two sides, and MC2 and MS2 and P2 is again the different membership fees and the per transaction fee charged to the two sides, the sum of the per transaction fees, such that the platforms maximize their profits and agents have no incentive to switch to another platform. Any equilibrium in this model involves a single active platform with zero profits. Why? Suppose all consumers and suppliers register with one platform, say 1. What is the best the platform 2 can do in this situation? Divide and conquer. Divide by subsidizing one group, say consumers, to convince them to join. And then other groups will follow due to network effects, and thus the market can then be conquered. All agents will then switch to intermediary or the platform 2. So, for such a divide and conquer strategy not to be profitable, the competitor must not be able to recoup the subsidy being paid to consumers. In equilibrium, the agents must receive the total surplus, and the active platform cannot make a strictly positive profit. This is also because the platforms are perfectly symmetric and non-differentiated, and there's no way for them to be earning any value. So the only strategy or the equilibrium for the platform is a zero profit equilibrium, where it subsidizes full participation, first by charging the maximal transaction fee and making zero profit by actually offering membership fees which lead to a negative value to consumers, where this is the negative this is the negative expected value that consumers will be getting, right? And this is going to be added to their in a positive way. This is being subsidized to consumers. Okay, so what lesson do we learn from here? That when we consider a matching market with two properties, first, participants on both sides of the market care about the size of the other side, and second, the platforms are non-differentiated and compete in membership and transaction fees. Then only one platform dominates but makes zero profit. Further, there's a small deviation here where we're going to discuss, does Google have market power? Current proceedings of the European Commission against Google are based on the assumption that Google has a dominant position. The legal basis has been Article 102, which is the fundamentals of European Union. Okay, and any abuse by one or more undertaking of a dominant position within the internal market or in a substantial part of it shall be prohibited as incompatible with the internal market, insofar as it may affect trade between member states. Okay, and similarly, a judgment by the European Court of Justice said that the dominant position referred to in this article refers to a position of economic strength enjoyed by an undertaking which enables it to prevent effective competition being maintained on the relevant market by giving it the power to behave to an appreciable extent independently of its competitors, customers, and ultimately of its consumers. Next, we try to understand something on platform pricing and regulation. So this also has implications of antitrust and regulation. What is First, let's discuss what is exercise of unilateral market power. In platform markets, efficient price structure may not reflect the cost structure. Prices above marginal cost do not necessarily indicate market power, nor do prices below marginal cost necessarily indicate predation. It is also wrong to think that multi-sided platforms exhibit subsidization to conquer markets. An increase in competition in multi-sided markets does not necessarily result to a more efficient or balanced price structure. A monopoly situation is not sufficient indication of market power. A lesson to be taken from here is that to be effective, regulation and antitrust assessments must be based on an accurate understanding of the way each market operates. In this respect, it's crucial to recognize the possible multi-sided aspects of a market, and sticking to a one-sided logic may lead to wrong decisions. Some important review questions is: which two instruments does a platform have to charge its consumers? What information is necessary to evaluate market power of platforms? Why can it be profit maximizing to set a price below marginal costs? Under which platforms is it optimal to set a price below marginal costs? Next, from the platform's point of view, which side should be subsidized? What are the characteristics of the side that should be subsidized to maximize profits? Compared to a monopolist, why does a duopolist put twice as much emphasis on the external benefit of one group when it sets a transaction price to the other group? And why is a monopoly situation not a sufficient indicator for market power?